Hello everybody, my name is Dimitrios Kanoulas. I'm professor at UCL Department of Computer Science. Unfortunately today I couldn't be there with you, so I had to deliver a very much smaller talk on the topic. So today I'm gonna briefly speak about the good, the bad and the ugly when it comes to legged robots, and I'm gonna mainly show you some videos from the lab, some successes and some failures when we were using legged robots. Right, so animals and robots, they all have their good phase. So when things work, they walk, they jump, they move in the world. Sometimes they have bad days, so failures that mainly they are recoverable, and then sometimes they do really have a really bad day, a very ugly day where things are not recoverable, and they're breaking really, really bad. So the problem is that if we want robots, such robots, in the real environment, then we need to take care of robustness, efficiency, safety, and agility, to name some of the issues that we have when we run things outdoors. So here are some examples of our lab demonstrating in urban environments, mines, forests, and agricultural fields, right? So we need robots to move around safely and robustly, efficiently, and with the agility that is required per case. All right, so let's go to the proprioceptive control. So we have the good part, which is things really work. These are just some examples. I'm sure out there are millions of examples now of quadrupeds, bipeds, monopeds, and so on, legged robots walking around, being pushed, having different gaits, being very, very robust, and this is quite impressive, to be fair. Although things are breaking, so let's say that a robot can somehow slip, fall down, and for this purpose we have developed ways of recovery from the ground through standard techniques or learning-based techniques in different morphologies of legged robots. Unfortunately, we have really big failures also in the lab. So robots failing for one reason or another, breaking legs, breaking sensors, falling really off the terrain in a way that this is not recoverable. When we start adding sensors and we have extra perception, I would say, for trajectory planning, then things become more interesting. So here you see the classic NMPC controllers running on spot, or we have classic RL-based parkour on on Go1, working pretty good, and I'm sure you have seen that around, although a lot of times things start failing a little bit, and like slippage of the ground which is not detectable, some obstacles that somehow the camera didn't get them correctly, and the method is failing, but still the robots can recover. Unfortunately, there is the bad part, which is, the robot really fails and breaks, really reaching high torques or falling on objects or falling from objects, and this is something really, really non-recoverable sometimes. Last, when we have to do with cognitive navigation, in a lot of times things work really, really well. So on the left side you see our diffusion based methods where we have global and local path planning, where the robots really navigate nicely in the area. On the right side you see a traversability analysis where the robot finds paths in the natural environment and moves along them very nicely. Unfortunately, sometimes even this is not working correctly, so on the top right part you see like a very shiny object that probably the sensor cannot detect it as an obstacle, so it stuck there. Or on the left bottom you see that the traversability analysis works somehow, so it doesn't fall on objects, but it goes really off of the path that we wanted the robot to go in. And this can become much worse. So here you see that local path planners can be really failing and falling on the on obstacles, or the robot is completely lost. Here you see that the robot starts spinning and spinning because I think it doesn't know where it should go, what terrain is traversable or not traversable, and these are big failures. So that was it from me. I have to have a last slide about the like what you will probably hear from others in this workshop, which is exciting, which is what's next. So what remains to be done in legged robots, and in my opinion there are a bunch of things that they're still open there. So how we can go from reactive recovery to proactive resilience, right? So not really to handle the bad cases only, so recover from failure, but how we avoid the ugly phase, because this is a catastrophic failure. All right, energy aware agility. So what if we care really about how we let these robots work for multiple hours in an efficient way while they're robust? This I think still is a problem in the community. Whole body cognitive contact. This is something really nice. So what if you want to avoid failures, but really not just use your legs, but use the whole body to try to recover from the bad instances. And last but not least, I think, is learning from the bad and ugly experiences. This is what I believe humans and animals do. So when you have a bad and ugly experience, you learn from it and you carry on with avoiding similar situations or handling them differently. And this needs to be online, so in a lifelong learning phase. That's it for me. I hope it was not tiring. Enjoy the rest of the conference and enjoy China, and see you next time. Thank you very much.